Yeah, because I had to move the window. That's why I've been playing with only one hand. So this. And today we'll be writing, scripting, researching, all sorts of stuff. Well, this sort of stuff more specifically. So, well, let me just make sure everything is set up correctly. At some point during the live show I should really also eat something. See, I already introduced you, no reason. Act 2, scene 1 right now. Do I have a plot twist for you? Anyway, right, so, such, and etc. We have rights to be scripted and scripts to be written. Like, for example, the Lagrangian harmonic oscillator introduction, and then Lagrangian mechanics. So let's get to it. I also should more possibly maybe make some coffee. That could be nice. I don't have any sugar. I should really go to the store today, because I only now realize how much I'm missing. Now I'll figure it out later. For now, jeez, that is dense. Okay. Introduction to Lagrangian mechanics. Usually Lagrangian mechanics are from the first large-scale diagonal system. Apply the equation. More correctly, if mass of moment inertia is constant, the equations are okay. In any case, we arrive at most of the differential equation of the integrated solution space in terms of solution. Most of us have many problems that sort. There we go. Rise to be scripted and scripts to be written. Someone quote that. Oh, if you're looking for great quotes, then well, there will be too many to note down. What do you think of Manim, the scripting tool to visualize math? I think it's fun. It's good. It's a really nice engine. I never remember if it's Manim. Oh, it is Manim. Okay. And we have 5 business here. Manim, animations, fun calc. And let's do, I don't know, 40 ball. Why not? It is Manim GL. I was mistaken too. Manim GL doesn't work either. Alright, I don't feel like fixing it. You will have to trust me. Didn't he use Manim before? I have used Manim before in many of my videos. I do believe that I've even used it in one of the recent ones. Actually. In the past I used to use it in around like 20% Manim, 80% Blender. But recently I've moved on to Blender more and more, simply because Blender is, I really like it. But now that you mention it, I think I used it recently. In the 5D chess is not 5D, this video. That was a half a year ago. Wow. Right. Right, that was half a year ago. Unrelenting passage of time. This is the unspoiled produce in the fridge. Okay. Generalized coordinates. Okay. In two dimensions, the position of a point is specified by rectangular coordinates or with polar coordinates. There are possible sources of spherical coordinates, spherical coordinates, and the see the molecule model in square angle recommendation of them. We shall call these coordinates Q1, 2, 3. Yeah. If we are thinking of single particle in three-dimensional space, there will be three of them, which will be rectangular, cylindrical, spherical. If these are n particles, will be three n coordinates describe the system, etc. There's coordinates Qj is usually generalized forms. Bj is defined as followed. As follows in the work required. Okay, this is all pretty simple. Can the future just wait? Can the deadlines come? Fashionably late, I can push every goal back. They control back. If they roll back, the rate at which time starts to fly. Never stand by, never taking a break, ever making me retry. Holonomic constraint. Alright, let me look up what holonomic means. One of those fun math words. Holomorphic, holonomic, holograms. Okay, that's actually surprisingly simple. Hey, make it. Doesn't Lagrangian use actions or something? Yeah, I mean, we already had a stream on Lagrangian. I'm doing a refresher. Because I don't want to put everything on the Remco. If I don't research it by myself as well, then I won't learn. Incidentally, I look at the word holonomic. It's pretty funny. This as an example, consider a bar of width so linear on the whole sphere of A is A. I only know Newtonian. Have you not been paying attention in the live streams? It's the difference of approaches. So F is equal to MA, your classical beloved Newtonian, but then you also have the partials of the Lagrangian, which Euler-Lagrange, if I'm not mistaken, if I recall correctly, is this dt partial L partial x minus partial L x dot. Because for some reason it's not. I still don't remember what the reason is why mathematicians note it down this way. This is meant to say like that these two are equal. You have your Euler-Lagrange, from which Euler-Lagrange or Lagrange. That's confusing. Too many people in physics in the past. Which gives you your beloved. Well, not really gives you, but makes it easier to work with your beloved delta L, which is x dot m, if I'm not mistaken. Yes, it's x dot m, which gives you your canonical momentum definition, Lagrangian mechanics. Then you have your Hamiltonians, which work in a very similar way, but you work with the Hamiltonians of Lagrangian, because if you don't like the letter L, then use H. Genuinely so similar. Quantum mechanics we also went over on streams. Quantum mechanics in which you just turn everything into linear algebra, basically. motivated by so why am I getting into this right now actually? We'll get into it later once I turn on the camera and we're working with a piece of paper. This section might be tough. This is going to be fun. I don't like all this summation stuff any more than you do. Oh my god. I love it when people explaining it are just aware of it because it's always brilliant. It makes for incredible explanations. The thing is, I am dumb. But these are not difficult. If you don't understand it, that's not because you're dumb, only that's because you're overwhelmed by the notation. Don't worry. The thing is, so far, the videos I've been making as a part of this checkpoint, they all lie on a very singular path. So, if you just understand them step by step, then you should be able to build up to... So, the brass and cats, that will be relevant in the future, and Taylor expansion will be relevant in the future. For now, derivatives, partial derivatives, harmonic oscillator. These three, if you watch them one after another, and if you understand them, then congratulations, you have everything you need in order to understand the Lagrangian formalism. Hi, the figure, by the way, hi. And particles. In the force I particle here, particle into the system, particle action, realize coordinates, and change of. Okay, so we have these coordinates, and what we're effectively saying is we have every single force, so sum of all of the forces, correct? These are the forces. Oh wait, I breezed through generalized coordinate, but I should probably remember the notation. That's important. I saw the vid and I haven't fully got it, but I have the basics down. What confuses you about derivatives? Okay, this is neat. This is neat stuff. I'm not gonna lie, the video of the derivative had too many lines. I couldn't grasp the idea you were referring to, and also you forgot to prove the derivative, if I remembered right. Resurima, I did specifically mention at the end of the derivatives video that I would move it for a future video, the partial derivatives one, and I did leave it for the partial derivatives video. Why the hell derivatives in ddx form? My brain wants to cancel out the d's, but I have to remind myself notation and so on. Well, the reason why, Panzer, is because dx is not equal to d times x. Think about it this way. You have a variable you call a, alright? That's your first variable, a. And then you have another variable that you call may. Why not? That's what you call it. These are just the names of the variables. You cannot cancel out the a's because they are just the names. dx isn't equal to d times x. dx is a completely different variable. There is no variable d, in fact. The reason why it's noted down d by dx of f of x most of the time is simply for convenience's sake. Because actually this means df dx, change in d, change in x. This doesn't mean d times x, this is a singular chunk, dx. If you would like, you could use different notation, and for example, you could say that you define, instead of using dx, you could use, I don't know, delta of a subscript x, for example. And then it would be delta f divided by delta x. Does that make sense now? Because dx is a singular variable that's meant to represent a certain shift on the x-axis, whilst df is a certain variable that's meant to represent a certain shift on the y-axis, like so. You divide one by the other, you get the slope. dx is some change in the x-axis and df is change in the function. Yes, exactly. That is precisely it. It's not d as in some kind of scale. It's not the magnitude d multiplied by the direction of x. That's not it. It is a full thing. Change on the x. So you could note it down maybe d subscript x. That could be a bit clearer, but that means the same thing. You're not being ignored, Nanostariko. I just don't find your comments helpful in this scenario. Because you really shouldn't, if you want to think about it this way, then you also shouldn't think of derivatives as a function. You should think of them as an operator. Because that's what they are, effectively. They're operators. Okay. Good, thanks, make it. I really hope you did. If you have any more questions, just let me know. I suppose maybe in that scenario I should have explained it better in the video. In the new video, I do believe I have made that, well, in the new video, the derivatives, we've been using a bit more like physicists, less like mathematicians, I suppose. Although not quite either. So let me actually see. Have I not made this clear? Because I might have not. That's what I meant on the very beginning. That's why I, throughout the entire thing, there we go. As you can see, throughout the entire thing, I wanted to refer like a single color to it. And x and y in this scenario is equivalent to delta x and delta y. Having a partial derivatives is a good tomorrow, wasn't too much. Partial derivatives is not that difficult. The jump from no derivatives to ordinary derivatives is more difficult than from ordinary derivatives to partial, because partial derivatives are just derivatives in one direction, that is it. When you mentioned h and you like had a POV of x and h, can you like re-explain it? I'll check the timestamp. Okay. What's the partial? Yes, that is the partial symbol. How are holonomic constraints defined? I mean, okay, I know how they're defined. How are they? Because right here we have the partial of a holonomic constraint in relation to this. 8, 10, everything you need to know about derivatives. Right, basic. So here's the idea. Here's the rima. Imagine your function f of x equal to x. All right, that's it. Simple as it could be. In that scenario, when you have a derivative, it's calculated by f of x plus h minus f of x divided by h. It's calculated by this kind of function. However, crucially, if you graph this function, you would notice something interesting. Mainly that if your h actually is equal to 0, then what this function would effectively be is it would be just a line, flat line on 0, like this, with a hole right here, hole of a single point. Wait, actually no, not even, it would be completely holes, now I think about it. Yeah, because I would need to, I would need to explain the plane. No, I did just realize that the reason why I did added the plane in that video is because it wouldn't make sense of a plane, because it's undefined other than in scenarios where h doesn't equal 0. I made an equation on harmonic motion too, but it follows Newtonian. That's all I can use confidently, don't judge. Oh, that is a lot of variables there, or a lot of constants. I unfortunately don't know what means panzer, because I don't know what these variables would be. How should I put this? Because how can I explain this without a plane? Okay, so right, this is how we're going to explain it. First, we're going to set our h to 0.01. In that scenario, what we get is 0.01 divided by 0.01, or in other words, we get a 1. That's simple. Then let's say that we set it to 0.01, like this, 0.001, like so. Then what we get is, from our equation, we get it equal to dot 0.01, 0.001, like so. Once again, we get a 1. That's simple. But what if we set our h to 0? If we set our h to 0, what we get is 0 divided by 0, which is undefined. That is incorrect, that is wrong, that cannot happen. You cannot have a 0 divided by 0. You cannot have division by 0 in general. So, how do we remedy this problem? How do we fix it? One thing you might have noticed is that whilst when h is equal to 0, it fails, that's true, but if it's close to 0, there is a certain value it's approaching. In this scenario, all of those values would just be a 1. So that's the reason why we don't just set it to 0, only why we take a limit as h is approaching 0. That's basically what it means. The reason why I've shown it on a plane is because I wanted to show that if you have a planar function with h being in one direction and x being in another direction, then this entire plane will be defined except for an infinitely thin line down the middle where h is equal to 0. And even worse, that line down the middle is exactly what we want. That would be our derivative. So our entire derivative is undefined, which is why we take a limit, which basically means approaching every single point from both sides like so and seeing what it approaches, seeing what it gets to. Actually, I don't know if it's from both sides now I think about it. It could just be from positive. I don't think if negatives matter for the sake of derivatives. I mean, same difference, it works in the exact same way. But it could be either that it approaches from both sides and it still has the equality, or if it approaches from the one side because we don't care about h going from the negatives, which is also quite likely. That is completely irrelevant. I think it can approach from, I think it's both sides, because when the function, because a slope at a point, yeah, it will make sense both sides. Although I haven't looked into it, so first of all irrelevant, second of all not important. And the change in R can be expressed in terms of changes. Okay, but R are the holonomic constraints. Or maybe they're not. The R notation is throwing a bit for a loop. I guess I should do R with spaces on both sides, or at least on one side. You are not a character! Oh, you cheeky bugger. You absolutely cheeky bugger. That's gonna be terrible for me. Okay. Alright. Because the full constraint is R is equal to A. I'm trying to figure out what R is. I'm guessing, if I had to guess, I would say that R is a generalized coordinate, Q is a generalized velocity. But I don't know if I should be going on guesstimates. R is equal to radius, perhaps. This is meant to be a generalized system. So radius wouldn't really make sense in here. I'm guessing this is... No, but that would be position in relation to velocity, it has to make sense. The ith particle undergoes displacement, delta r. So r really looks like a generalized coordinate. The total work done the system is f times partial ri, the physics notation. Position vector r of a particle can be written as a function of its generalized coordinates, and the change in r can be expressed in terms of the changes of in the generalized coordinates. Thus, the total work done on the system is R is a generalized coordinate, Q is a generalized coordinate. Hi there, Levan. Hi, welcome. How am I already crushing burning this quickly? And this is okay. I mean, the first part, that's easy. The second part. Oh, or is that sum included in there? My goodness, the sum is included in there. I am such an idiot. In my defense, the notation makes it pretty rough because this Ri depends on this sum I, which means that this is no, that threw me for a loop. I thought there were two separate sums. F I times sum, way too many loops, j partial ri partial qj delta qj. Okay. How come integrals identify surface? And why do we actually need to calculate the antiderivative for it? I don't understand the question. Fi, okay. So then we have two generalized coordinates. We have generalized coordinate r, we have generalized coordinate q. Like so. Then this will be change of, we're taking a particle, we're taking the change of its generalized coordinate in relation to another generalized coordinate. What is the q? From one to another. The I particle undergoes displacement of the Ri. That makes sense. I found the main channel 2 3 weeks ago. I almost watched every video on the channel. I hope you like them. I wouldn't recommend watching the old ones. The old ones are quite terrible. Incredibly good, I would say. Well, I appreciate you saying that, and I will work harder to make sure that even more will come in the future. In fact, that's what I'm doing right now. Change in generalized coordinates. That's the total. This is partial derivatives throwing me for a loop. Because this really does appear to be the partial of a certain generalized coordinate in relation to another generalized coordinate. Or this is meant to represent another particle. But if it was supposed to represent another particle, then why not just use R as well? Why use the Q? Sorry for skipping almost the chemistry ones. My heart is broken. You know how much quantum mechanics there is in a lot of chemistry videos? Well, applied quantum mechanics, but still quantum mechanics. I am still so confused by what the Q is. This is really hard to see if it's really explained somewhere. Hold on. Integrals usually calculate surface between the function graph and OA. But the issue is, I can't grasp why should we calculate antiderivative of a function and subtract fa, fb? Well, it's because that's your starting and end point. If you have a certain area, like, there we go, this goes on forever, to the left. To the left it's going on forever, and if you have this as your red area, and then this as your yellow area, then red minus yellow gives blue, indigo. So if you're interested of something from A to B, then A minus B equals the area between them. But how come it identifies the area? I don't understand what you mean by that exactly. Because there was a segment about integrals. Which, I mean, I won't lie, it's not bad, of course. So basically, FB identifies the area from B to OO. Oh, you're doing a lot of abuse of notations, Resurima. That's the problem. You're committing a lot of abuse of notation, and that introduces ambiguity. Because when you say FB, do you mean... Well, that depends on what you mean. If you have f of x dx, then you can go 0 to b, or you can go minus infinity to b. Or you can honestly go anything in between. You can go a to b, where a is just anything from minus infinity to b. You can do whatever you want. So when you say FB, which one do you mean? Sorry, I'm explaining things in French. I'm talking about your notation. I'm sorry. Do French have different math notation? Because I wouldn't be surprised. I'm sorry, I like laughing at the French, it's funny. Anyway, is Q some energy thing? That's what I'm trying to figure out. It is referred to as associated with generalized coordinates. So it's referred to as a generalized coordinate QJ. The thing that confuses me is that it really makes it seem as if Q and R are just different generalized coordinates. So it's kind of as if you have one particle, another particle. This particle will have generalized coordinate R, this one will have a generalized coordinate Q, and even then that's not really true because that depends on the amount of particles, which means you have a certain set of particles where each component of the R vector would be a different, right? Wait, is Q and... No, that wouldn't make sense. Do you on Discord? Yeah, you can send on Discord. Yeah, well, English. I mean, not having a vocabulary to express yourself in English is absolutely fine. The thing that confuses me is that I don't understand what capital F of B should mean. Because there is there are functions that are defined this way, it's pretty standard. So for example, you can define g of t, for example, to be an integral from 0 to t of f of x dx, like this. But then you can also replace this 0 with, well, whatever you want. And that will mean something different. F of x dx, so you can have a 0, you can have minus infinity, you can have anything. What if R and Q are two sets of particles? Well, then it wouldn't make much sense, because if they are two sets of particles, then taking a partial derivative of Ri to Qj would basically mean that if you have two particles, for example, then this would be taking derivative of this to this. So how one particle is changing on a certain coordinate in relation to how another particle, or actually, well, I suppose it would be one-dimensional, at least I think it's one-dimensional so far. So, like this. A generalized coordinate, doesn't matter, they have their constraint. How one particle is changing its position in relation to another particle. This is displacement. This is force. This... Would it be dimensionless? Maybe. How are chemists organized in the physics? I'm assuming you are a chemist. I am in fact not a chemist. I just know chemistry a bit. Jack of all trades, master of none. Eventually master of all. We're getting there, slowly but surely. Definition generalized force, the work done system is also this. Okay, yeah, so this makes sense. This makes sense. Because right here what we have is we have a force acting on the displacement. Why is this here? I don't understand. Suppose that we have a system of n particles, that the force on the ith particle, I is equal to 1 to n, is F. That's simple. If the ith particle undergoes as displacement delta Ri, the total work done on the system is this. Makes sense. The position vector r of a particle can be written as a function of its generalized coordinates. Position vector of a particle, yes, that also makes sense. And the change in r can be expressed in terms of the changes in the generalized coordinates. This one throws me for... Oh my goodness! 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 Hi, the macaroni. Hi. Oh my goodness! Hold on.
What did I miss?
Well, not much to be honest. We've just been talking about physics and math.
Right?
Oh, the sneeze of wisdom. Grant me knowledge, because right here we have partial Ri, partial Q, Qi. Delta Qi and Qj, sorry, both these are J. And I think what's happening here is that this is just equal to delta Ri. I think that's what's happening, because you're taking a derivative of how Ri is changing in relation to Qj and then offsetting it the same way. So you can think about it, if you have a cube, okay, if you push it forward, given a certain... Oh, okay, that's difficult to explain. The idea behind it is simple, it's just a really difficult thing to explain.
I'm good with like understanding stuff.
Right, if you have a cube...
Intuitively.
Okay, so imagine that you have two different coordinate systems. So, is it Kronecker delta or not? I actually don't know if it's a Kronecker delta or... I felt that was just delta as in difference. I thought there was just difference
You're really
notation.
good at drawing cubes.
Thank you. I have a lot of practice. So, imagine that you have two coordinate systems. Coordinate system R and coordinate system Q. And they... I forgot the word for it in mathematics, where things map onto each other perfectly. That thing. Contain the same amount of information. Then I'm pretty certain that if you have something expressed in terms of change in the R coordinate, then if you take that change in the R coordinate and if you take a derivative of the R coordinate in relation to the Q coordinate, then I think you can express it in terms of change of the Q coordinate. Because you're basically, right here in the top scenario, you're checking how the object is changing in the R coordinate, and the bottom scenario, you're checking how it's changing in the Q coordinate, and then how the Q coordinate is changing in relation to the R coordinate. Basically chain rule. Does that make sense?
I guess so. You gotta explain to me what a derivative does again after I go for a run.
Right.
Because I didn't watch the video.
Just watch the video.
No, you're here now. Anyways, I'm gonna go for a run, and then you explain to me what a derivative does, science man.
Okay.
I like your funny words, science man.
I cannot even...
Right, see ya later.
See ya, bye. this would make sense. This would certainly make so much sense then. We're checking, so we have two generalized coordinates, Q and R. Okay, we're going to proceed assuming I'm correct, because I always am. So, then we're writing it out like this, that makes sense. Then, by definition of generalized force, work can be done in the system also. Yeah, so this is our second system of generalized coordinates, that makes sense. And then what? We have this. Oh, that is hefty. Right. This makes sense, but it feels like it shouldn't mathematically work. I'll take his word for it though, because what we're basically saying is, I mean, yeah. Pi the power main, hi. PJ is equal to this, that makes sense. Force equal mass r, that also makes sense. Mass times acceleration, also time derivative of... Oh jeez, right, this right here is just... PJ I think, broken down? No. This is the Ri coordinate to Qi coordinate multiplied by velocity of Ri. Okay. Right. Multiplied by R dot I. So this is the velocity in the R coordinate multiplied by the change in the R to Q, and all of that taking a derivative of which would give us acceleration, if I'm not mistaken. I'm worried that this is meant to be a force though, and I'm missing out on the mass. Is QJ mass? That would make everything. That would make sense. Why would you take ever generalized coordinate? It doesn't matter. And then this right here. Oh, it does look to be mass. It looks suspiciously like the equation. No, it isn't. Okay, no, I'm just losing myself. I'm losing my mind. Oh, we're taking out maths from both sides and then added this. Huh. Handbooks hide important information, the accused of being easy to see. The problem here being that I'm kind of jumping into this in the middle, so I imagine this is just known notation. Right. It's a bit pixelated, but we'll work with it. So basically, this right here gives us, my guess would be acceleration. Can I lower the size? Thank you. My guess right here would be acceleration of the Q coordinates. Or rather, yes, actually. Hi, the Tefta, how are you doing in Texas? Acceleration, this would be acceleration of the R coordinate, but with this portion right here to tie them together. This would be acceleration of the R coordinate. Oh, this is chain rule. Is it not? No, it isn't. Workshop shouldn't make it at the moment. Well, I'm glad to be distracted with the workshop. What are you working on? I sent the DM. Should I send somewhere else? Ideally, not the DM. Ideally, I would recommend the math channel on Discord. This arrow makes it very misleading. This actually product rule. I mean, obviously this is the product rule. The question is, what is this? Come to the yearly meetup and I'll speak as a director of all this as a panel. Oh, that's fancy. That is really, really fancy. when I have two equations that are set in the same way, like a plus b times c equals d and e plus f times g equals h, how do I know describe something when these letters could mean completely different things? Context, always context, absolutely always context. That's how you do it. Because if you have just the letters, you can't know, but it's always about the context. So in this scenario, since they say that r is a generalized coordinate, right? And if they say that q is a generalized coordinate, based on that, I'm assuming that these are just two different coordinate systems, and the partial is just used to switch between them. Okay, hold on, because Resinima has a question. Is that r double dot into something? R double dot, well, okay, r double dot is acceleration. So this would be acceleration. I'm thinking this is just coordinate conversion, which would mean that this is acceleration of the coordinate conversion plus velocity of how coordinate conversion is changing over time. This part doesn't make much sense to me with the micro understanding. But one thing at a time, Resinima has questions, let me see. A is equal to okay. F of velocity at the point. The derivative means the rate of change in the area. Resinima, I have a question for you. Have you actually seen my derivatives video? Okay, so I'm going to use the same exact example as I used in the video. You have a function like this, right? Now, I'm trying to answer the fucking Cauchy sequence. Oh, hold on, because this might be interesting. Is the Cauchy sequence the one I remember? Cauchy sequence. What do you mean when you say you're trying to understand the Cauchy sequence? Because I might be able to assist if it's... I might be able to assist with my most mathematical video I have ever made. Would have still displayed video of one of my favorite purely math videos. Make a question. Is the chain rule like chainable? Like, say we have a function h of g of f of x, then can we apply the chain rule twice? Yes, we can. we absolutely can, and we do in fact do that quite a fair bit. In the video about partial, once again, I really wish, listen, I'm fine with all of you asking me questions, but I mean, most of the questions you're asking about just involved me mentioning videos from the past. And I'm not saying that like, I'm fine with you asking me questions, but my goodness. Because what I'm about to do, Panzer, is I'm about to bring up this portion of the partial derivatives video where I say, let's see, this is the chain rule, so called because no matter how many nested functions you've just got a chain of derivatives together. This right here. I'm really fine with questions, but you are all making me feel like I'm wasting my times with the videos. This is your f of g of h of k of l of x. This right here. Because also to you, Rezorima, I will say that if you are confused, I'm guessing what you are specifically confused about is why does integral create the area under a function if it's an antiderivative? Which, if I am not mistaken, I have also showcased in my most popular video on the channel, right here. And this is actually pretty spot on. This is the exact explanation I would have given. Which basically is that, how should I put this? I'm trying to find a different way to put it then from the video. The gears video, yes, the gears as well, the gears, yes, the gears were used to represent the chain rule. Also like last year. The whole point there is that the reason why a derivative works the way it does, let me think of another way to put it. There is another way to explain it. There is. You're multiplying, not operating multiple derivatives. Differentials are made of functions, not operators. What do you mean? No, derivatives are very much operators. They very much are. You cannot, like, you cannot have a derivative of a value. You have to have a derivative of a constant. I mean, the function, sorry. You have to have a derivative of a function. If you have a derivative of a constant, then the only reason why you can have it is because you just consider it as a function that's equal to a constant. Like dy dx, dt dy, dy dx, not dx dy. No, the second one is correct. Rude, the second one is correct. The first one is a simplification that works most of the time, but the second one is correct. You should think of operators as just acting on stuff. So basically, we just know. So basically, when you have multiple derivatives, if you evaluate them, then yes, you can multiply them. But if you don't evaluate them, then you need to operate an operator onto an operator. You can't just do it like that. You can't just, they're not functions. In fact, it's a pretty big deal that they're not functions. Once again, I'm going to refer to Ash's paper on Taylor expansions, which is that Taylor expansions are kind of trivial and obvious when we're talking about, they're kind of trivial and obvious when talking about functions, they're used really often, but when it comes to operators, well, you need to actually check if you can Taylor expand an operator, or how does it work, etc. Operator valued Taylor expansion. Even then, I suppose it's an operator valued function, because that's what the time evolution is. It doesn't matter. Can I have a fractional derivative? If I'm not mistaken, yes. I don't remember how it works though. I do believe you can have a fractional derivative. I am. You just have to know there's some kind of. I don't. That wouldn't even be number theory at that point, would it? There is some kind of just mad. I don't know. I'm almost certain you can. Yeah. Okay, I have been wildly distracted. I was supposed to be doing all this stuff. We have this. Oh my goodness, that's Euler-Lagrange, isn't it? That has to be. It is! Oh, this page is a gold mine! Yes! Oh yes, this page is a gold mine. Okay, I would need to, either with Ash or Remco, double check my understanding of this. But this this page is really a gold mine. Out of many fields of math, make it only knows. What do you mean I only know applied? Panzer? Panzer? Ouch! Just straight up fucking ouch! Make it Panzer. Welcome back, Macaroni.
Hey.
You have done Cushy for arrows. I tried instead using point sequence. I think I can do that, right? Yes. Well, I haven't done Cauchy for arrows. I visualized the sequence with arrows. The underlying mathematics doesn't change. It doesn't matter how you visualize it. The underlying mathematics doesn't change. So whenever you...
Farmain. I'm not German.
Yeah, Farmain was talking about Panzer.
Oh, gotcha.
But yeah, the Cauchy sequence is just a sequence. I really hope this works. Assertions in 48 and 49, so in here. I was correct! Oh my goodness! It feels incredible! Wow! Make it, if you had a catchphrase, would it be expected as a representation? I already have catchphrases. So many, in fact.
Which ones?
Make the best out of a good situation is one of them. Egg on my face. That's another one I tend to say quite a lot. Because if you became Technocratic Mage in Mage Center, would you be the New World Order Mage, Iterationist Mage, Void Engineers Mage, Predator Mage, or Snicklist Mage? That's a good question. I'm honestly torn between Iteration X Mage and Syndicalist Mage, personally. We will need introduction to the model, we will need generalized coordinates, we will need afterwards Euler-Lagrange. We will need, what will we need after Euler-Lagrange? I suppose, well, from that point on, whatever we want, I don't know, canonical, momentum, because why not? Yes, we'll have the example, then we'll have applying the model, and that should be it for the video. Are we going to discuss generators? Not yet, because they're not necessary yet.
I mean, generators are just, how's it called? Electric magnetism.
I think
Or solar.
I think root code is talking about the mathematical generators.
Oh.
But no, that's way in the future. It's not relevant right now, as far as I'm aware. I could be wrong. This is really neat, I have to say. Alright. It's been how long? It has been an hour-long live stream and I've written absolutely nothing. I know views you got last 2 weeks was rough, but you're making next one already. Maybe that's what makes you punk rock. I have made, in the past 2 weeks, I've made 5 videos. Well, I've uploaded 5 videos.
Hi, Bav.
Hi, Buff. Hi, welcome. If you think that... I feel like it's been pretty clear for quite some time that I am not doing it for the views.
He's doing it to send a message
Exactly.
to the YouTube overlords.
It's about sending a message. Okay, then I would like to plan out one more video.
Maybe the real punk rock was the friends we made along the way. I need to finish my paper.
Alright. Okay, let's do... Lie algebra and group theory would be fun. When we get to particle physics, fine. Or even better, when we get to the strong interaction, fine. That's when that's when I'll do a pass on Lie algebra. Group theory will probably come beforehand.
Tablets that after ingesting creates helium cavities in your bloodstream. What the... What? So, as far as I understand it, a derivative is just, how's it called? It's just you take how's it called? A point point on a graph, was it a graph? I think it was a graph. And you see what the slope on that part is,
Yes. Yes.
right? Alright. Good.
Make it. Any strange progress? After the stream, I'm planning on watching some more of them. Was trying yesterday, but the entire day, I've just been working, unfortunately. Today my plan is for the entire day, I'll just be scripting 3 videos and working on the website whilst watching the strangest of things. My reaction is that they named the carry path from glue on. That's the thing that makes you pissed. Have you? I'm sorry. The color charge of a gluon doesn't upset you. So okay, because this is something that needs to be spoken out. You know what colors quarks can have when it comes to color charge? They can have 3. They can have the red. They can have the green. They can have the blue. There are also anti-particles, we don't care about them for now. Right. So they can have this, or they can have the anti-colors. Anti-red, anti-green, anti-blue, doesn't matter. Now, when you have a gluon, then what the gluon means is that you have 2 quarks, and you have just a gluon slingshotting between them, gluing them together. And that gluon also needs a color charge. So you know what kind of color charge it will have? Well, obviously it's going to have a combination of 2 out of these 3 I've mentioned before. So how many color combinations can the gluon have? Well, obviously, 8. And now I will just give you a second to think about what I just said.
8.
8. A gluon has 8 possible colors it can have.
What?
I really would suggest, if someone wants to be really confused, I would really suggest you draw yourself out. You draw yourself up what kind of possible colors a gluon could have.
Whiskey bottle for Remco, that would cure his delusions about crap.
Whiskey bottles is what caused the graviton thoughts. I showed your videos to my teacher and he subscribed to your channel. Oh, thank you. I appreciate that actually. That's really nice. I like that a lot. Have I made any problematic jokes in my recent videos?
No, you make it. Can't say that. Shouldn't say that on YouTube.
Yeah. I mean,
My
I
favorite,
don't.
In fact.
I don't mean the extreme ones. I mean, yeah, like, you know, comparing myself to a god or stuff like that. Because I do that from time to time.
That's what you mean.
Yeah, that could be a bit of a weird thing for some teacher to stumble across. You need to make sexual innuendos in your vids. They can't be played at school. Yeah. What I need is some kind of method to get rid of kids. But I guess for now I'll start with getting rid of kids from watching my videos. The getting rid of kids in general, will do that in the future.
Also can have flavors
But of them can make cheese. I think physicists are just hungry. I think they're just all day sitting in these rooms. They don't realize they don't eat anything.
But we cooked up to glue on.
A very family-friendly channel. You have become a very family-friendly channel for the last 6 to 10 videos. I refuse to believe it was 6 to 10 videos. No, because last video before the charity one, if I recall correctly, was Taxi already. A column 3 engine, yeah. Before that, it was me hacking ID cards, which starts with me just... If I recall correctly, the intro to this video was... And let me make sure I remember. I don't think YouTube's even gonna play it.
More like 6 to 7 videos apparently. Says from a main. You having a drinking problem.
Yeah. Why have so many problems with gravitons? I just want to be recognized. Oh yeah, do you want to be living? Do you want to be living in a 5-dimensional universe?
Yeah, of course.
Teachership. I'm not even 10% down. I have to finish it until next Tuesday. With enough caffeine and Adderall, anything is possible.
I mean, Adderall is, you know, prescription drug.
Still, it's incredible. Alright. Let's do some work on the website. But it's not much yet. Actually, it's your last old Make It video. After that, it's usually mature, responsible, science educator, and Make It arc. I would like to be competitive, but I mean, that's kind of true. Yeah,
Partition?
Yeah, watch the Emperor had a text-to-speech. The Grafton, that one guy sitting there, sad that he's not canon.
I watched TTS, yeah. It was good.
It really was, yeah.
Very good.
Quite funny.
So sad that James Workshop smited it. Then until James Workshop came along and everything changed when James Workshop attacked or something. Don't think it's corporate greed directly, but more like corporate incompetence that they don't notice as free advertisement.
Yeah.
Won't make it.
One day Old Make It will return.
I mean, but why is corporate greed? They didn't lose any money from it.
Yeah, they weren't. I mean, I'm with Macaroni on this one. Corporate greed would suggest that they were losing money or not making as much money from it, which they weren't.
Or that they could make more money by striking it down.
Which they couldn't.
They probably lost some money doing that.
So Jay, you now feel like a Spider-Man who is middle-aged father but still wears mask every night. I hope I'm not a middle-aged father. I mean, as far as I'm aware, I'm not.
No, because corporate greed would then, on your why not both example, is because if it was corporate greed, then it would have to imply that somehow they were losing money because of it, or potential money because of it.
Yeah.
Like, yeah, but like, it's a fan animation, it's fan content. If you want official Warhammer stuff, you're gonna watch the official Warhammer stuff.
And I don't think they even make money from people watching official Warhammer stuff. That's once again just advertising.
Exactly, like Root Cult says, Nintendo doesn't lose money from cancer patients with murals, but they still shut them down. It's corporate stupidity. No, Space King is, see, the thing with Space King is that it's something technically different. It's technically different enough that you can't say it's copying from Warhammer.
It's distinct in the best way, legally distinct. I didn't say they lost money, they wanted more for themselves. Free Funimations would be a rival. Rival in what? I don't mean to be that guy, but have you seen official Warhammer animations versus Emperor's text-speech device? I'm not saying that one of them is... I'm not saying they're in a bit of a different fields, but they kind of are. My thoughts on the whole Greenland situation? Oh no. What?
This is not a political channel.
This is not a exactly. By the way, I just realized that I still have my comfort streamer playing in the background. I didn't turn off the stream yet, so this entire time I had it playing in the background. Yeah, it's Michigan Code of Claims, 20.00094 mm, David Krieger. I've been just following it up every now and then. It's
And you're still doing that. It cracks me up so much.
I never stopped. This is a really, honestly, honestly, the shenanigans they get up to. Oof.
Watch out that they don't copyright strike you for showing this.
What are they gonna do? Take me to court?
Said that he was scared even if it was very law, but still he wants to do a slap on what? GW will do W slap on him and their new family back then. What is new family? I don't get it.
Can you stream Outer Wilds on 1100? I've already finished Outer Wilds. I haven't played DLC though. It's a great game, you should definitely play it. I won't tell you what it's about though.
Yeah, because if he told you what it's about, then he'd ruin the whole experience. I had spoilers, sadly.
Ah, damn it.
But I wasn't gonna play it anyways.
I shouldn't even have it downloaded actually. Probably enough. Hold on.
The lawsuit would tank his family to make it back. Oh.
No, I still don't think it's... I still think it's stupidity, not greed.
Yeah. Same here.
You should make a video where you spin a wheel to decide which addiction to participate in. Personally, League is back in my daily life. Coping mechanisms wheel. I genuinely... I would... I imagine that's part of Jay Rich's daily routine, to be honest. I imagine him, like, next to his bed, there's like a comically large wheel with... that he spins, with lights and everything and music. Alright, play League of Legends on day 1000. You know what, Jay? Just for you, I will play League of Legends on day 1000.
Dear God, he's gonna build a time machine.
Oh, I have so many tabs open. this turn off, this turn off, this turn off, this, fine. Okay, what's the most probable bit? Until the integrals part, and now I get it a bit, but I still need to think about it. Yes. Basic idea being that derivatives tell you how the function is changing. And if you take an... So it basically is going two ways. You have a function, its derivative tells you the change of the function, so the function is changing. However, with that information, you lose the information of how much it has already changed. If you go the other way, however, with the integral, I suppose it would be easier to show if right here you go with the derivative, the dx, right here you go with an integral. When you're going forward with the integral, however, then there we are. Then in order for you to get back the original function from the changes, you need to add up all of the changes. You need to add up how the function has already changed, which is equivalent to taking the area under the function, because when you have a function up to a certain point, and you take an area up to that certain point, then you can imagine each one of these heights as represent that value of a function. So this is kind of like a sum of all of these areas, all with different notation, like this, where this is your sum, this is the height of the rectangle, this is the width of the rectangle, like so. Is dx 1 technically? Yes. You can, I mean, actually I don't know. Now that I think about it, I don't actually know if it is. Hold on, let me double check. It depends.
I mean, it should be because it's the same, isn't it?
No, not
Yeah.
quite. That's because it is possible that it could be defined, because you need to define dx somehow. And,
Oh, gotcha.
and if your definition of dx would be h approaching 0 of x plus h minus x, x plus h minus x, then this could still be undefined. I have this incredible idea for a video, building chemistry up to from elementary particle interactions. I've already done it backwards. I started with chemistry reactions, and I was breaking it down until we got to elementary particles.
Let me break it down for you, Mark.
My goodness, I'm starving. Okay, I think that will be it for today's stream, because I will not be lying. I woke up on the wrong side of bed and I'm already... and I'm exhausted. I'm exhausted and I'm hungry. I haven't even eaten anything yet. So anyway, I'm gonna go. I'm going to be scripting, as I mentioned, the 3 videos. I'm going to be scripting the website. And for now, that'll be it. Thank you everyone so much for watching, and have a great day.